In lesson 8.1, we're going to talk about correlation. So a few vocab words before we get started here. Bivariate data is data that involves two variables. So we're going to be talking about two different situations that can change. And scatter plots are graphs of this bivariate data as a set of points whose coordinates correspond to two variables. So scatter plots mean that there's dots all over the graph. They're not necessarily in a perfect straight line. And we'll talk about the different types of those here in a second. And then correlation is what is shown when you graph those. They can be positive, negative, or no correlation. So when your information is graphed, you'll have these dots. And if you see an upward trend, if you're looking at the graph from left to right, if the dots are kind of going in an upward fashion, that's going to be a positive correlation. If they appear to be going downwards, like the middle graph here, that's negative. And then if they're all over or in a straight line straight across, or they're all over the place, there's not an up or down appearance to them, then there is no correlation between the two variables that are graphed. So the table here shows the number of species of mammals on the International Union of the Conservation of Nature's Red List of Endangered Species during the years 2004 to 2012. We're going to make a scatter plot using this data, and then we need to figure out what type of correlation is there between the number of endangered species in the year, and what is the trend, and is the number of endangered species increasing or decreasing? So quite a few questions there to answer once we graph. All right, so the years are going to go at the bottom, and I have to go from 04 to 2012. Go by twos. And then looking at our list of numbers of species, it looks like 348 is the smallest and 450 is the largest. So I'm going to make this little squiggly here, telling that we're going to skip some numbers and we're not starting at 0. So I am going to go up by 5s. Well, if I got to go 100, that's probably not good. I'm going to go 10s. So what did I say the smallest number was? 348. So I'm going to start at 350 here. 348 will be just below it. And we're going to have one up here in the words. Okay, so in 04, it's 352. So just above. In 06, it's 348, so just below. 07 is 349. 08 is 448. 09 is 449. 2010 is 450. 2011 is 447. And 2012 is 446. All right, so for the correlation here, there is no correlation because these 3 dots down here were almost in a straight line, and then all of a sudden it jumps up and these 4 dots are almost in a straight line. So it jumped way up here and then continued in a straight line. So it's not a pattern where they continually are rising throughout. So that's why it's no correlation. And then it says, what is the trend? So after, what year was that? 08. After 2008, the endangered mammals stayed around about, not 200, 450. And then, is the number of endangered species increasing or decreasing? And we're going to say neither for that, because they're staying about the same. All right, for the next one, it says describe this correlation, looking at the scatter plot. So if you read this graph from left to right, it appears that these dots are going downward. So this is a negative correlation. Now, for our next example, we don't have a graph to look at. We have to kind of either visualize our own or actually write out our own. It says, what would you expect to be true of a person from the survey who watches very few hours of TV? Is it possible for that person to have low test scores? Oh, I'm sorry. I thought we were going to have to, I didn't know it was the second part here. I didn't read ahead. All right. Who watches very few hours of TV. So TV watching time is at the bottom. And if you look, if somebody watches very few hours of TV, they would be down in this area somewhere. Is it possible for that person to have low test scores? Well, according to this, no, it is not. But does actual TV time really affect how you do on a test? Absolutely not. So is it possible for a person to have low test scores? Absolutely, yes. But according to this graph, it looks like it's unlikely. That's why it's called a scatter plot. So we could absolutely have other dots that were in here. So if somebody else took that test, their dot might be down here towards the lower end of the test scores. So this is just based on who they interviewed for this. The correlation coefficient measures the strength and direction of the correlation. So if it's if the strength is good, then the dots are all kind of pretty close to a straight line. If it doesn't have much strength, then the dots are spread out. So kind of like these pictures here. The top two are strong and the bottom two are weaker. And positive correlation, if they are close together in a positive correlation, so going uphill, like this one right here, that's going to be your R, your correlation coefficient, is going to be close to a +1. Now, if they're strong and so close to a straight line and going downhill for a negative correlation like this one over here, then R is going to be close to -1. And if they're weaker, then between R is going to be between 0 and -1 for the negative correlation, and between 0 and +1 for the positive correlation. So they are going to be farther away from that -1. So the farther they're away from that line, the farther they are away from the 1 or the -1. So this table lists the latitude and average annual temperature for various cities in the Northern Hemisphere. Describe the correlation between the latitude and temperature and estimate the correlation coefficient. So for step 1, we have to make a scatter plot. And then for step 2, we're going to describe the correlation and estimate the correlation coefficient. So I'm going to make the graph over here so we can see. We have latitude first. And as you can see, these are all decimals. to the nearest tenth. So we're going to have a real tough time graphing this accurately, but we'll try. Try to get it as close as possible. And then the y's are going to be the temperature. So looking at the latitude, it looks like the smallest is 13.7, and we have to go up to 55. So go by tens, maybe by fives here, starting at 10. And then our annual temperature looks like our lowest is 39.4 and our highest is 82. So I'm going to skip a few numbers over here as well. I'm going to start at about 40 and do the same thing, go by fives. All right, so the first one is 13.7 over 13.7 and up 82.6. And then over 30.1 and 71.4. Over a little too far there. All right, so what type of correlation do we see here? It looks like it's going downhill. So kind of in that fashion. So we're going to say negative correlation. And then estimate the correlation coefficient. So looking at these dots, they're pretty close to that straight line. And remember, you have to keep in mind that this is a hand-drawn graph, so it's not the best, but it gives you an idea. And all the dots are pretty close to that straight line. So we're going to say this is a strong correlation. And it's also negative. So our correlation coefficient is close to negative, close to -1. So R is. So it's negative correlation. It's strong because the dots are close. And because the dots are close to the line, that means that R has to be close to -1.